Hello everyone and welcome to my YouTube channel. In today's video we are going to take a look at how to train YOLO V8 on a custom dataset using Python. Now I have seen a lot of YouTube videos on YOLO V8 and almost all of them are using the command line interface and they're creating data using some kind of labeling tool. But in today's video I'm going to discuss what the data format for YOLO V8 should be, and we are going to be using Python for training and for inference. So YOLO V8 was released a while ago this year, and it's claimed to be one of the state-of-the-art object detection models. But I think we also need to look at segment anything now. So to install, we will be using YOLO V8 from the Ultralytics GitHub repo. So to install YOLO V8, you can just do pip install Ultralytics. And now we try to see if we can find some dataset. So if I go to Hugging Face, here we have datasets, and inside that I can find many object detection datasets, many in different format. But the one that caught my eye was this plastic and river dataset, because it's a use case which is also applicable in real world, and it's if you're building a model for something like this and you're using it real world, you're doing something good. But the problem here is, again, what I've seen in many YouTube videos, the data is already in YOLO format. So the task is to detect 4 different types of objects, and if you want to take a look at what are the 4 different types, you can go to files and versions, dataset info, and here you can find the classes. So these are the 4 different classes: plastic bag, plastic bottle, other plastic waste, and not plastic waste. So you're given images of rivers or water bodies, and you have these 4 different labels that you have to identify. So whenever a new image comes, you have to find if there is one of these 4. So like in this image you have 4 different objects, 3 belonging to class 2 and 1 belonging to class 1, and you have been given the bounding boxes. So this is one bounding box, this is a second bounding box, and so on. The problem here is the data is already in YOLO format, so I can just convert this data set to how YOLO expects the data to be in, that we will see, and we don't have to do anything with the bounding boxes. But for object detection, the data can be in many different formats. So one of the most popular format is, let's go to VS Code now. So the dataset for object detection can be in many different formats. So you can have bounding boxes in which you have been given xmin, ymin, xmax, and ymax. So you have these 4 values. You can be given all the different coordinates: x1, y1, x2, y2, x3, y3, x4, y4, all 4 coordinates. Another popular format is, so this is one of the formats that we discussed just now. Another format is x1, y1, x2, y2, and so on till x4, y4. The third format is you have x and y, and you're given the width and height of the bounding box. So this is the COCO format. Now YOLO expects the data to be in a really different format. It's the normalized width and height, and x center and y center. So any of these formats can be converted into this one. So it's really easy to do that. So I'm not going to discuss that. And for the YOLO format, what we do is, let's say our data is in this format. So for YOLO format, we need X center, Y center, of the bounding box, and B box, normalized B box width. Let's add an N, and normalize bounding box height. So to convert data from this format to YOLO format, what we can do is we can take X and so this is simple mathematics. So we are taking X and adding width, half of the width of the bounding box. So B box width by 2. This is the first step, and in the second step you just divide it by the width of the image. Let's call it W. Oh yeah, this is also normalized, and this is also normalized by the width and the height respectively. Similarly, what you can do is you find the center of the height center, so Y and bounding box height, and divide by the height, and then you divide B box width by the width of the image, and B box height by the width of the height of the image. So this is something that you have to remember, and once you have the data in this format, you will be able to train YOLO models very easily. So just remember, like any of these formats can easily be converted into this format. It's just simple mathematics, nothing else. And you can write very simple functions. I have already done one video on YOLOv8 a while ago, and in which I have shown that how you can convert data from this format to this one. So you can take a look at that video if you want to do that. And today we are going to be looking at a data set which is already in a good format, so we don't have to do anything. So we have these images, we have the bounding boxes, so let's download the data set. I'm going to go back to VS Code. So let's download the dataset using the datasets library. So first you have to install Ultralytics. So pip install Ultralytics that we can do for training. So now we can do from datasets import load dataset. And now we can say if name equal to main, my dataset is load dataset, and then the repo ID. Okay, so let's print the dataset once we have downloaded, and let's also, there are 3 different splits. So one is train, one is test, and one is validation. So what I'm going to do is I'm going to print the first sample just to see how it looks like. And we go here in the terminal, YOLOv8, and I can say Python convert to YOLO. Okay, so let's see what we have here. We have train dataset, which has features image and litter, and inside litter you have label and bounding box. So bounding box is a list of list, and label is a list. And similarly you have train and test and validation. And here is your image. So image is loaded in in PIL image format, and here you have everything else that I just described. So now the idea is to convert this to a format which is understood by YOLO. So let's do that. I'm just going to, okay, let's just keep that. Okay, so for YOLO, you expect the dataset to be, folder called dataset. You can change that in settings, so you don't have to put the dataset in folder called dataset. And inside that, you must have images and labels, these two folders. Inside images, you can have training images if you have them. You should have them, and validation images if you have them. You can also have test split there. Similarly, here you have train and validation. And inside train, you can have images, let's say 0.png, 1.png, and so on. And inside labels, you will have a text file for each image. So 0.txt, 1.txt, and so on. So now how the text file looks like, that's also very interesting. So for each text file, let's say this is 0.txt. Here you have the label ID. So let's say the label ID is 1. And then the X, Y, W, H in the YOLO format. So the normalized ones, not the real ones. Okay. And if you have like more than one label, you can have, okay, let's say we have label 0, we have label 1, and so on. And if you don't have anything, the file is empty. So it's really very simple. Once you have data in this format, it's really very simple to construct something like this. Okay, so the data sets, and yeah, inside that you have images and labels. Okay, so now when we read this data set, we have to convert this to a format understood by YOLO. So I can just write os.make directories, so which is going to create directories for me, and this is going to be called datasets / train, and datasets / images / train, and I can say exists okay equal to true. So even if it exists, it's okay, it won't throw an error. And let me import OS. Okay, so we have that, and similarly here we have to do for validation, and we have to do both these for labels. So this will be labels and train and validation. Okay, so once we have that, we need to take the images from the dataset. Since it's already in YOLO format, we don't have to do anything to the bounding boxes. So we can just write a function, dump images and labels. And here I can specify the dataset itself and the split. So train and validation. So now let's read the dataset. Dump images and labels, and here you have dataset. So I'm also keeping a reference to the code, which I'm taking a look at from time to time. And here you have split. Okay, and so my data will be data, well, let's just call it data and split. So if I have train, I have training. If I have validation, I have validation. So for I comma example in enumerate dataset, data. I have the image, which is example image. What else do we have? Labels, example. Now this comes in another key called liter labels. Okay, I think it was label in the dataset. And B boxes, bounding boxes, example liter, and this is B box in the dataset. So now we initialize something, a list called targets. So we have the targets, we store the targets here, and for label, comma, box in zip, labels, comma, B boxes. Okay, so here we have targets dot append. So what my targets are. So as I mentioned, we start with label, and then we have box 0, 1, 2, 3. We don't have to do any kind of post-processing here, but if you have to do post-processing, you do it here. Box 0, one, 2, 3. Okay, and when you're done with all the labels, you can just write with open datasets. Was it datasets? Yes. Slash labels slash split. So this will become an F string slash I dot txt comma W. So we're writing to this file as F for target in targets. Just write the string F dot write target plus slash n. Okay, and we are done. But one thing we forgot, we also need to save the image. So image.save, since image is already in PIL format, it's easier to save. So datasets slash images slash split slash i.png. Okay, so we have saved the images, saved the labels and everything, and now everything looks good. So let's see if we try to run it and if we get some error. So Python convert to YOLO. So I think it's called exist. Okay, so let me fix that quickly. Okay, so I think for training YOLOv8, the most difficult step is creating the data. Once you have created the data in proper format, things are pretty easy from there. Okay, so now it's creating the data. We can take a look here. We have datasets, images, train, and inside that we have the training images. And similarly in labels we should have the labels generated. So as you can see, 5 is empty, no label found. Okay, so this will take a while, and once it's done we can start writing the code for training, or we can do that in the meantime. So let's do this train.py. Now, one thing the most videos are missing is they don't show you the documentation. So there is very good documentation, YOLOv8 docs, and you have the mode for training, and inside that it says, okay, from Ultralytics import YOLO. I've created a file called train.py in which I can just copy paste the code from the documentation. So let me copy that VS Code. Okay, so you have to import YOLO from Ultralytics, the package that you have installed, and then you can load the model. So like from a YAML file, you can load the model from a PyTorch binary pre-trained model. So this is recommended for training, and you can load the YAML and then transfer the weights. So what we are going to do, there are many different kinds of models, YOLOv8N, X, S, M, L. So what we are going to do is we're going to use the M model, which is the medium size model, and we are going to fine tune this model. And now you see here, we see some more parameters. So we have a YAML file, and I've already created a YAML file. It's also something that you have to do when you're training a YOLOv8 model. So it should look like this. You have the path. Now, since my dataset folder in the same folder as the YAML file, the path is dot. Then I have the train split, val split, test split. So for train, I have images/train. For val, I have images/validation. This is optional. I don't have that. And then the names. These are the class names. So 0 for plastic bag, 1 plastic bottle. This is something I got from the dataset. So the dataset you have, the number of labels. If you have 1 label, just have 1 entry here. Okay. Now image size. So this is also a very important thing, and most of the tutorials are missing it. So image size of my dataset is 1280 by 720, and so I'm going to train on this size, and I have, this is width and height, so you can specify that. And let's train for 20 epochs, and we have here plastic.yaml, the YAML file that I've created. Now if we go back to the documentation, you will see like there's a lot more going on here. We have a bunch of different parameters that we can tune, and yeah, it seems like a lot of people are missing on what to use, what not to use. So we are going to have a batch size of 4 so that it doesn't explode my memory, and everything else seems fine. Okay, maybe the optimizer, I can change the optimizer, and I can change the learning rate. So let's set the optimizer to Adam and change the initial learning rate. So batch size is 4, optimizer is Adam, and initial learning rate, the parameter is LR0, is 1E minus 3. Okay, so now we have everything ready, and YOLOv8, everything else is taken care of by the model trainer. So we don't have to do much. It's very few lines of code to train your state-of-the-art model like this. So let's try to see if we can train the model. So I'm just going to write Python train.py. Hopefully everything works. So it's downloading the model. Okay, so I got an error. Okay, so this is a simple error. It should be optimizer, not optimize. And we train again. Okay, so it prints a bunch of things. So now my application is running on this board. So that's TensorBoard. So I can take a look at TensorBoard if I want to do that. Let's see if that works. Okay. Okay, it doesn't seem to be working for some reason, but anyways, you have the TensorBoard logs. So I think I probably need to start TensorBoard to take a look at that. Okay, so no, it says that I have to start TensorBoard. Okay, anyways, so now what's happening is it's training the model, obviously, and it will create a bunch of folders. So you have this runs folders in which you have the training runs, and inside weights we don't have anything because still training the first epoch. You have a YAML file with all the arguments used for training, which is good to look at. Then you have the labels. So you have the 4 labels and you can see information about that. But the best thing is you can see like, okay, this is my training batch. And now if you have made any mistakes in labeling the dataset, it will be visible here. So like, okay, I see, okay, it's fine. There is no problem. The data set labels are correct. It was already in this YOLO format. So it will give you some batches of training that you can take a look at. So I'll let it train for some time and then we can take a look at the results and how to predict using Python instead of the CLI. Okay, so it seems like the training has finished. It was finished before. I just copied the weights. And we have best.pt and last.pt. So best is the best weights and last is the last weights. And you also get like a few more things like P curve, R curve, F1 curve. So these kind of things you can take a look at these if you want to do that. Awesome. So using this we can say, okay, if it's confidence more than 0.1, then we keep it, otherwise we remove it. So these kind of things you can infer from the results. And now we can create a folder, another file called predict.py. Okay, now we write the same code like before. So we have from Ultralytics import YOLO. We have from datasets import dataset. Okay, and here we had we load the dataset. So let's load the dataset here too. And now I'm interested in one single image. So let's say IMG is dataset. Let's look at the test split. Test 0, the first sample, and image. So this gives us a PIL image, and we can load the model now. So model equal to YOLO, and inside that we have runs detect weights best.pt. So we just load the best model from the runs directory. And now we can say our result res is model.predict on this image. So this returns a list of dictionaries. So we can just say, just give me the first one because I have only one single image, and you can print res.boxes. So this will print you the bounding boxes and everything. So let's see if this part works. So Python predict.py. Okay, so like I'm getting some predictions. So like it says class is 1, it gives me some confidence, and it gives me the bounding boxes in different formats also. Okay, but what we want to do is we want to plot this. So I will say res equal to res.plot. Okay, and here there is a parameter called line width. Let's say line width is 1. So this is just the width of the line used to plot. And now you have to remember that this image that you got is in BGR format, so we have to convert it to RGB. So for that we can just do all and flip this one. Okay, so now it's converted to RGB format, and it's a numpy image, so we've converted to PIL image. So from PIL import image, and here I can write res equal to image dot from array res. So I'm just using res for everything. Res dot save output dot png. Okay, and this is also a very important step, converting from BGR format to RGB. Okay, now I run predict, and let's see what happens, if it even works. Okay, so this worked, and here I must have output PNG image, and here you can see like 2 plastic bottles have been detected. So yeah, pretty cool, right? We fine-tuned YOLO model to detect plastic waste. I think that's a pretty cool use case. Let's run it on a different image. Okay, here we go. Oh yeah, so this is like detecting other kinds of plastic waste. All of them are other kinds of plastic waste in this image. So yeah, pretty good. I definitely recommend you to take a look at the documents for the predict function, because there's a lot more you can do, and you can also make cool videos like people make with the live webcam. And here is the code for that. I'm not going to show you that because I cannot use the live webcam right now. But yeah, you can also have like you can supply a path to MP4 file. Okay, and it accepts data in many different formats for images, for videos, and also like for like if you're giving an image, you can have data in PIL format, OpenCV, NumPy, Torch, many different kinds of formats. So this was about YOLO-v8 object detection. Maybe if we find it interesting, maybe we take a look at segmentation task or pose task in one of the future videos. So that's it for today. Thank you very much for taking the time, and I hope this video was useful. If you think it was useful, then do click on the like button, do subscribe, and do share the video with your friends. Thank you very much. Bye.